Yeah.
And so fast forward to Einstein, right? There's some problems when we look at Newton's laws of gravitation, right? And Newton's laws of gravitation actually come off the back of Kepler's laws, right? If you look at Kepler's third law, it's actually Newton's law of gravitation. Anyway, but all Kepler's laws are Newton's are tied into Newton's law of gravitation. Newton came after Kepler.
To be honest, when I was younger, when we did that in school, I really used to like that stuff. That was some of the stuff. I think that pushed me more into the whole.
Right. It makes sense. It makes sense. It's like this. It's like a story in math.
Exactly.
Yeah. And it's like logical, and you don't need to learn French. Right. Well, maybe you need a little bit.
I think for me also it was like you can model and see it. Do you see what I mean? Like mechanics and stuff like that. You can also see it, so you can therefore predict it if you get your model right.
Yeah.
Which is different from some aspects of maths and science as well, because some of it is kind of way more abstract, or you have to have that logic brain that just gets to it straight away. But these kind of things, just sorry, I know I'm adding something, but like, for example, it's like, throwing a basketball in the net.
Mm-hmm. Yeah.
That motion, obviously you can model that. Can't for the life of me even remember what that stuff is now. What you call it?
2D kinematics, yeah.
Yeah, kinematics, right?
Yeah.
But you could, and it doesn't even have to be 2D. It could be 3-dimensional, because obviously when I went to uni, we started doing it, partial differentials and all of that stuff.
Yeah.
But the principle that you can tell somebody how to do that thing, have them do it. I guess it's the applied science aspect. I think that's what the beauty of some of this stuff is. Because it's
you could build a machine to always hit the net.
Exactly.
Right? Yeah. Problem with humans is we're not very good, right? We're not good machines, right? There's all sorts of errors, right? You can even I mean, it's the same physics that goes into missiles, quite frankly, and
the self-landing. What do you call it? I can't remember. The Elon Musk's.
The Falcon 9 core stage landing. On the barges and on the lands. It's very similar, but it's not in free fall, right? When you throw a basketball, there's no further impulses on it.
Of course,
exactly. With a rocket, you're going to go, and you can see those thrusters changing the way it's falling. But going back to genius, right? So Einstein's genius was to say, well, maybe Newton's law of gravitation, right? Newton, Newton. Maybe Newton wasn't quite right. And that is where a completely different approach to understanding gravity came from. He goes, well, maybe it is in fact, you can't decouple space and time. These two things are intertwined. And so by understanding gravitation in terms of a distortion of space and time, you come up with general relativity, right? And so that now is the explanation that we have to use for spaceflight, right? You can do large satellites on obvious orbits using Newton's laws of gravitation and Kepler's laws and stuff like that. So how long does it take something to get to Mars? You can do that with Kepler's third law.
Yeah.
But if you want to have precise locations on the surface of the Earth from a satellite that's at an altitude of 30,000 miles, right? A GPS satellite, you need to do the corrections, the general relativistic corrections in order to get your position on the surface of the Earth. So that's now the understanding that we have.